So these are the three sums. I think we have got two sums more to show you, the different practices. We did all cost function sums. Now let me show you a revenue function sum. Now look at this. The marginal revenue function for output x is given by MR is equal to 4 divided by 2x plus 3 whole square minus 1. Find the total revenue, almost similar to that of cost function. We are given, in this case, given that marginal revenue is equal to 4 divided by 2x plus 3 whole square, okay, minus 1. We are actually find what? Total revenue. So let us say this is ddx of r, where r is the total revenue function. ddx of r is given 4 divided by 2x plus 3 whole square minus 1. So this implies dr will be equal to 4 divided by 2x plus 3 whole square minus 1 and then dx. So we'll now do integration in order to find out the revenue function. So integration of dr will give you r, and then we'll get integration of 4 will be outside. We'll get 2x plus 3 whole thing to the power minus 2 dx and minus integration of dx. Okay. So that way we will get r is equal to 4 into this will give us 2x plus 3 whole thing to the power minus 1 divided by minus 1. And then we have minus x plus k, where k is the constant of integration. So this gives us r is equal to minus 4 divided by 2x plus 3 minus x plus k. So this is the revenue function. Find the total revenue function and the demand function. Okay. The marginal revenue function for the output is given. Find the total revenue function and the demand function. Okay. So revenue function is this, okay, and the demand function will be r by x, or average revenue function. It's same as the demand function. So that will be equal to minus 4 divided by x into 2x plus 3 minus x upon x plus k upon x. So you are going to get minus 4 x into 2x plus 3 minus 1 plus k upon x. That will be your demand function. Okay. So I'll do a recap. So marginal revenue was given to us. From there, we have found out the total revenue function by taking the integration. And then once we get that, in fact, I was just looking for conditions so that we can find out the k. Condition is not given here in this function. So we move to demand function. Demand function is equal to average revenue function. So we found revenue function divided by x per unit, and we got the demand function. Okay, so that's how you do the sum with respect to revenue. The next sum, if you look, it says when an industrial machine is 3 years old, it generates revenue at the rate of 6025 minus 8 square rupees per year and results in cost accumulated at the rate of 4681 plus 13t square rupees per year. For how many years can the machine be used to maintain profitability? It's a very interesting question. It is said that there's a machine which is being used, and in 3 years, the machine generates a revenue of 6025 minus 8t square, and the cost that is being accumulated is 4681 plus 13t square. Now, the question is, for how many years can the machine be used in order to maintain profitability? And the second is, what are the net earnings generated by the machine during this period of profitability? So if you have to find out for how many years the machine can be used so that the profitability is maintained, then we have to equate these two. Till the time your revenue and the cost are equal, so you are at a break-even point. So that way we can get an equation, and from there we can actually find out the value of t. So let's try doing this. Okay. So we are given for profitability, we will have R dash T is equal to C dash T. So the revenue as well as the cost function should be equal. So you are given 6025 minus 8T square is equal to 4681 plus 13T square. Okay. This implies, so we have, if I shift 6025 minus 4681 is equal to 8T square plus 13T square. This will give us 4 again, 3 and 1 is equal to 21T square. Okay. So therefore, T square is equal to 1344 divided by 21. Okay. So this will be equal to, if you do cancellation, you'll get 64, if I'm not wrong. One sec. Let me do it here. So it's 21 into 64. 4, 6, 8, 12. 4, 4, 3. Yeah. So T square is 64. Therefore, T is equal to plus minus 8. Since T is the time period, so it cannot be negative. So we'll have to take, therefore, T is equal to 8 years. So that means the machine can be used for 8 years to maintain profitability. Beyond that, if we use the machine, so the cost will be more than the revenue. So we got our first part of the answer, that for how many years can the machine be used? The machine can be used for 8 years. Now the next part, what are the net earnings? In these 8 years, what are the net earnings is what we need to find. And for that, we need to find out the difference between the revenue and the cost, because that will give us the profit. And over a period of 8 years is what we need to find out. So what we have to do is for net earnings, net earnings will be, so you have to do R dash T minus C dash T. This you have to integrate it over 8 years. Okay, so dx. This is what we have to do. So R dash T will be equal to, how much is it? 6025 minus 8T square minus C dash T is 4681 plus 13T square. Okay. And this will be in terms of dt. So we will get integration 0 to 8, 6025 minus 8T square minus 4681 minus 13T square and dt. That will give us 0 to 8. The difference is 1344. We did it earlier, minus 21T square dt. So if we continue, okay, we will get is equal to, this will be integration 0 to 8, 1344 dt minus 0 to 8, 21 outside T square dt. In other words, we will get 1344 T. We can put T 0 to 8 minus 21 T cube by 3, 0 to 8. or 1344 into 8 minus 0 minus 7 into 8 cube minus 0 cube. Okay. So that will give us 1344 into 8 minus, how much is 8 cube? 8 into 8 is 64, and 64 into 8, 64 into 8, 512. So that's 7 into 512. So that way we will get 2, 5, 7, 0 minus 14, 8, and 35. Okay. So I'll leave it. We'll not do the subtraction. Subtraction will be your part. If you have understood the sum and you have done the calculations, please do the subtraction and find out the answer. So there's a box here for you all to do the subtraction and find out. So this is how we can actually calculate the net earnings, which will be the difference of revenue and cost over a period of 8 years. Why 8 years? Because we have already calculated previously and we found that the machine can be used for 8 years, ensuring that we get profitability. We can't use it beyond that. Okay. So that's a whole lot of application of integral sum for today. In the next class, we'll take up vector, which is the last unit for your unit 4. Thank you so much.